Okay, so good morning, ladies and gentlemen, and welcome to the very first topic of HCIP, R&S, IEP. So IEP is all about implementing enterprise network engineering projects. So really, in this module, we're simply going to do topics that are related to implementing enterprise network engineering projects. Actually, the very first topic is what we're doing right now. It's on network planning. We're also going to do a topic on network design. How do we design a network? Then how do we implement? So network implementation. We're also going to do a topic on troubleshooting. How do we troubleshoot network problems? Then how do we make them better? So network optimization. Lastly, we're going to do a topic on network migration. If we want to move our network, for example, from one location to another, how do we go about that? So good morning once more and welcome again. Let's begin with network planning. This is one of the most interesting, by the way, and impactful modules because it provides a lot of know-how on how to go about implementing network projects, and is especially useful to managers, ICT directors, and anyone else who's interested actually in staying around in this industry or even starting a business. Okay, so I'll read the forward. So network planning is the very beginning of a network project, and a sound network planning creates a good environment for the implementation of follow-up phases of network implementation. So during the network planning, we make an analysis of the project background. So we want to understand why this project, then make clear customer requirements and objectives. So what do they want and what do they want to achieve? So the objectives, and also to determine the project's technological roadmap. So in network planning, we don't focus a lot on the technology that we're going to use, but we just get a rough picture of the technological direction that we are going to follow from actually the customer requirements and also their budgets. So network planning is the very beginning, the very first step in implementing a network engineering project. So by the end of this chapter, you should be able to, Mr. Gadudi?
Upon completion of this section, you will be able to understand the concept of network planning.
Yes.
Master the method of network planning. Perform network planning properly.
Oh, yes. Thank you very much. Okay, so we're going to begin with an overview of network planning. Then we're going to talk about the project background, objectives, technological roadmap, and we're also going to review a project case. Okay, so let's begin with the overview. So as I mentioned already, network planning is the beginning. It's the very beginning of of a project, and also is the basis of the future work. So all the future phases really are tied down to the network planning phase. Now, the project implementation cycle is normally divided into what we normally refer to as PDI or I. So P there for the acronym, PDI or I: planning, designing, implementing, then operation, then improvement. So PDI or I. So As you can see, really, the very first step is planning, network planning. So network planning will cover details such as setting up the project's objective. We want to understand the basis of this particular project. So these objectives must be SMART. I know you already know what SMART means. They must be definite, measurable, and they cannot be blurry. They have to be very precise and clear. So that is number one on planning. The other thing you need to do on planning is understanding the general background of the project. So you need to ensure that you understand all the exterior factors that are needed in order to enable a smooth deployment of this particular project. Now, you're also supposed to determine the work scope. So let me just do a simple list here. So here we want to do project's objectives. To understand the project's objectives, we want to understand the project background. Number three, we also want to understand the project scope. So what is the scope of this particular project? And it is from the scope, for example, that we can slightly know the budget, for example, and all the other resources, all the resources that are required for this particular project. Now, other than that, we are also supposed to create budgets during planning. So we can also create budgets, which will help us just to approximate really the budget. So these are some of the things that we do during planning, and most of the time we use what we call a visibility research to see how possible this particular network project is. So really, normally we make an analysis on the economical aspects of this particular project and the technologies that are supposed to be used. This helps to guarantee what we call the return on investment and also the total project success. So that's why we are doing this feasibility research in order to actually get a clear picture of the technological direction that we're going to follow, and to also have a look on the return of investment and the probability of the project success. So planning is it that we are beginning with right now. Okay, so the next phase after planning, as you saw, the next phase after planning is actually designing. Now, again, planning, it focuses on understanding the requirement of the project from the user, from the customer. Let me use the word customer, from the customer. So you have to do a requirement research. It also requires that you understand the exterior conditions that are needed for implementation of the project. So some things that are beyond computer networking. For example, electricity, for example, air conditioning, and so on and so forth. So those are the basics about planning. Really, planning focuses on what you want to do and the conditions that are required in order for you to do that particular network project. Now, what about design? Now, design, on the other hand, focuses on technological implementation. While here, on planning, we can have a technological roadmap where we depending on the user requirements, we know that for us to implement this is the direction we need to follow. But the details about the technology in terms of the equipment that you're supposed to use, the cabling that we're supposed to use in order to achieve the customer's objective, really they are done during the design phase. So They're used to meet network requirements confirmed during the planning using various technical methods, which we're going to look at. Now, theoretically, these two stages, planning and design, are actually, as you've seen in the previous picture, they follow each other in sequence, planning, then design. But in reality, when you implement network projects, you're going to realize that these two phases are actually combined with each other closely. Yeah. Uh, for example, things like the budgets, the personnel that are needed for the project are included in the project planning, yet they are related actually to the detailed project design and operations. So really, project planning and project design, as you're going to notice much later, are closely done simultaneously. So please remember that. Okay. Now, what are the main objectives? What are the main objectives of what we are calling network planning? Now, we have three main objectives. One of them is the project background. The project background is used to establish the exterior conditions that are needed for a network project. As I said, for example, you need a room, for example, maybe you need racks, maybe you need air conditioning systems, maybe you also need electricity. So those exterior conditions uh, must be established when you're trying to establish the project background. So a network project really is not an independent system. It also uh, 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 relies on other exterior conditions. Mm. Now, the background and these conditions are actually established by doing research. So you need to do a research, and we're going to see some of the ways in which you can use in order to establish this particular information. The next objective of planning is to determine the requirement. The next objective is to determine the requirement. Now, in determining the requirement, really you're trying to understand the objectives of the project. So you need to understand and clarify the customer requirement so that you have a comprehensive and accurate project objective. Why do they want to do this? Why do they want to do this? What do they want to achieve? How is it going to impact their business? So that is about the requirement determination. And also you need to understand at this stage the technological orientation. Technological orientation. Remember, this is not technological design, but orientation. So here you just want to select a technological roadmap. A technological roadmap. So here you're trying to understand really the customer's technological inclination, major concerns, and any taboos, if any. So we just want to understand, for example, what are the speeds they would prefer, and we want to also advise them in terms of cost, so that maybe we can have a balance between, for example, the speeds that they want and the cost and their return on investment. So that is really some of the things that you're talking about when you talk of the technological roadmap. Okay. Now, as we said, in order for you to understand the project background, you need to do research. Now, this research is done majorly by use of surveys. So the survey is used to obtain information about the project. Now, these surveys can be done in one of four ways. You can actually do talks, or you can create survey forms, or you can actually write emails to do queries. You can write emails to do queries and get responses. And you can also work together with the team so that you understand in detail what they want with the customer, so that you get actually first-hand material about the project and what they really want. So during the project background phase, the most important thing is, after collecting the information, you need to do that through a lot of communication. So you need to coordinate with customers about the project's objectives, the technological roadmap, through all these things that we've talked about. And I think here they're also adding things like meetings. So really, at this part, we want to do a lot of communication with the customer in order to understand what they want. Now, at the end of the network planning phase, we need to write a report. We need to summarize all the first-hand materials and all the consensus that we've had during the survey, and any communications that we've had through meetings, talks, emails, etc., etc. Now, once you do that, you need to share. You need to share this report with the customer and any and the members of this particular project team. So actually, this report is important because it's the one that is going to be used to guide the entire work that you're going to do to this particular customer. So it actually serves as the basis for coordination with the customer. So you have to ensure that the report is clear and concise as much as possible. So let's begin and look at the first subtopic or objective of network planning, which is project background. Now, project background, as we've said, is done through surveys most of the time for us to establish and know really the background of the particular project. Now, generally, we are doing this in order to avoid any mistakes and to also leave a very good impression on the customer. Some of the things that you need to establish during the project background is, for example, the background and characteristic of the industry. So, for example, is it a telecom network? Is it a cyber cafe? Is it a university? Is it a high school? What do they do? What are their potential for growth? What are the numbers of users? So some of those characteristics about that particular industry, you have to establish them. The other thing you have to establish is the characteristics and process of their services. So for example, what services are transmitted on the network, and what is the service process? So what services are transmitted on the network? Is it telephone data? Is it live videos like what we're using right now for virtual learning? Is it internet data packets? For example, they're going to be watching YouTube and accessing other high bandwidth internet sources. So the other thing you need to understand is the background and the objective of the project. So what this means is you understand the reason why. Why do they want to create this network? Reason for initiating the project and what they're expecting to achieve. What is the results and how is it going to benefit this particular company? So it is from these three that you'll be able to understand the overall background of this particular customer. So that is very important. Now, in fact, in order to do surveys and establish what we call the project background, you must understand the customer's organizational structure. Other than understanding the customer's organizational structure, you should understand how it relates to your own organizational structure. So that is the engineering party. So this is important, and you need to understand each bit of this. Now, generally, every organization has a CEO at the very top. So, for example, here we have the CEO of the, for example, Multimedia University, who's, for example, the Vice Chancellor. And here we have the CEO of this particular company, network company. Now, here we have two lines. We have an incomplete line, which is dotted, and we also have these complete lines. Now, what these incomplete lines mean is that we have rare communication between these parties. So, for example, the CEO of the customer and the CEO of this other side might not communicate regularly unless, for example, they're communicating about very high decisions. For example, about the project contract, about financing, and so on and so forth. So they're not going to be communicating so much during the project implementation. Now, in that particular organization, for example, Multimedia University, we have the department manager. For example, at Multimedia, we have the ICT director. Now, the ICT director will most frequently communicate to the project salesman of the engineering team. Now, in the engineering team, we have two people that are very important and are going to be greatly involved in the project implementation. That is the project salesman and the project manager. Now, you can see that the ICT director here will be communicating regularly with the project salesman. Now, generally, the project salesman really is responsible for the regular communication about the project. For example, establishing and doing those surveys in order to understand the user requirements, coming up, for example, with the work plan and following up on that particular work plan. So that's why they're going to be communicating regularly with the department manager, but they don't understand a lot of technicalities about the project. Whoever understands the technicalities and is going to design and implement the solution is actually the project manager here. So the project manager here is also going to be discussing a lot with the project director on the customer end. The project director, for example, can be the network and system administrator at Multimedia University. So this guy really, this particular project is under his directorate. Now, other than these two, we also have a project contact and also the project team member. Now, these are the people that are going to be on the ground most of the time, the project team members, and most of the time they'll have someone who will take them through the institution to show them the different parts of the institution, to show them where the hostels are, to show them where the pavilion is, to show them around. And they're going to be there all the time throughout the project in order to make these people comfortable and understand the environment that they're going to work in. So generally, these are the main people in the project. Now, finally, we have the end users. These are the people that are going to benefit and use the network. Sometimes you might also involve the end users, especially during surveys and so on and so forth, in order to establish the basic customer requirement. So they are also an important part of this process. Okay. Okay, let me just mention something that the project contact, this guy here, the project contact is responsible for routine affairs, such as leading engineers into and out of workplaces. So they're going to be there most of the time. Now, on the other hand, during the planning and the design, we communicate more with the project director. So the project director is actually a techie, most likely heading that sub-directorate. So this one is going to be used for that particular purpose. While during project implementation, we communicate more again with the project contact because he's the one that is showing us around and guiding us in what to do. So really, the project contact here, it's important to also understand. We said that for the department manager, we can have the ICT director there. This is the vice chancellor, the CEO of the university. Here we have the ICT director. Then in the ICT directorate, we have a subdirectorate, the network and administration subdirectorate. So that person, the head of that subdirectorate, can act as the project director. Under his subdirectorate, he has some employees, for example, ICT support. So they're the ones that can now act as the project contact. So this guy is also a techie, by the way. Okay. So any question here, by the way, or comment? I want us to be discussing a lot in this particular module. Any question or comment? Okay, so let's look at one of the things that are done during project planning, which is determining the scope. The scope. So the scope of the project really is how big is the project. We normally look at this from different perspectives. The first perspective is what we call the functional boundary. So in terms of what are the functions? What are the functions that are needed for this network? And therefore, what modules are needed in order to realize those functions? So that is what we call the functional boundary. Then you have the coverage. Coverage, simply put, relates to the geographical area that that particular network is going to cover. So is it just a LAN, is it a MAN, or is it a WAN? So geographical area, how big the area is. Then the engineering boundary. The engineering boundary. So responsibility division between the project and other matching systems. Now remember we said that a network project is not an independent project. It relies on other, what they're calling here, matching systems. For example, the equipment room where you're going to install this equipment, the power supply, air conditioning, cabling. So some of those other matching systems must also be established in order to determine the project scope. Okay. Now, many projects are divided into phases or cycles so as to break it down into specific subcomponents. Now, one of the ways to do that is by using what we call a work breakdown structure. An example of a work breakdown structure is what we are having here. So it really divides the scope of the project into smaller, manageable components. So look here. So at the beginning, we start with discussion with customers, then we go to planning, then we go to design, then we order the equipment that we need, then we refine the solution, then we implement the solution, then we do testing, then we agree that we've met all the requirements, and therefore we deliver the project and begin operation and maintenance. So this is an example of a work breakdown structure. It really shows you the components of the entire project. So here at these particular points, as you can see, after discussions with the customers, you need to do a contract signing. You also need to do another contract signing just after the design, because now everything is clear. Because you cannot plan and design before you have a contract. At this particular point, for example, they need, before you begin design, you need to get a bid issuance. You need to get, you're now officially being given that project to carry on. So that is what we call a bid issuance. Then normally we have a preliminary acceptance after implementation before we start trial. And after trial, you'll have to be on site for some months. And finally, they are going to give you a final acceptance certificate. So if they give you a final acceptance certificate, now they're supposed to pay you your entire amount. So this is an example of a work breakdown structure. Now, normally, this goes hand in hand with a tool called the Gantt chart. So the Gantt chart actually sorts the activities in time rank. So after dividing the work plan, so after we come up with the work breakdown structure, now we can now put times at the time. So this one is going to start here and end here, followed by this one here and end here. So I'm sure most of you are already familiar with how a Gantt chart works. If you're not, please Google. So really, it combines the activity with time points in a chart. So really, it arranges the work within a phase and the time that it's going to take in order for that phase to be deemed complete. Okay. So we said that a network project is not independent. It has what we call matching systems. So matching systems are systems that are closely related to the project. So they need to be focused on and confirmed by the project team. So for a computer network project, you need to find out about the power supply and whether, for example, a power backup is needed in order to ensure availability of your network, whether the voltage is what is needed, and so on and so forth. You need to know about the cabling. You need to know about the air conditioning and the equipment room. So the equipment room is where all these are going to be installed. So the equipment room, and also the rack where you're going to install the switches and the routers. So all this must be considered, and they are what we're referring to as matching systems in a network project. Now, cabling, network cables. So network cables are actually the connection lines that are used to interconnect the different devices. For example, between switches, between routers, or between switches and routers. And sometimes cabling for a local area network is actually defined as an independent project, just like air conditioning, power supply, rack, and so on and so forth. But it depends on how you're going to agree with the particular client. But most of the time, cabling is actually viewed as a weak independent project. So that's why it's also, excuse me, that's why it has also been put under matching systems. Now, during planning, we must also try as much as possible to establish the risks that are involved in this particular project. And in this particular slide, we are looking at the exterior risks. The reason as to why it is important to identify the risks early enough during the planning stage is so that we can reduce the possibility of this risk occurring, or if it occurs, then we also minimize the impact of this particular risk to our project. Otherwise, if we don't do that, then any of this risk occurring can actually lead to the failure of our project. Some of the exterior risks, why we call them exterior, let me see, is because exterior risks usually out of control of the project team. So you don't have a lot of control about this. So project risks refer to series of uncertain factors that influence the progress, efficiency, profit, and objective of the project. So some of the risks include policies and regulations. So you must know, be aware, and conform to all the policies and regulations of that particular area where you are implementing your network project. So for example, we have certain policies and regulations that guide certain network, wireless network frequencies. There are frequencies that are free, for example, the ones that we use for Wi-Fi. There are others that you have to get a license. For example, the ones that we use for LTE, for example. So you need to know them. The other one is social environment. So when you talk of social environment, is just understanding the society, their norms, their taboos, their traditions, what is deemed right, what is deemed wrong, so that you don't go against any of their norms. So that's why you need to understand that. The other one is natural disaster. I think we all understand that things like earthquakes, storms, so they can actually affect our project. We also need to understand something to do with coordination. We've looked at matching systems in the previous slide. So there are other things that have to be implemented by other subcontractors, like the air conditioning, etc. So sometimes they might actually delay your project because if they're not well handled, they can actually cause the delay of your project, because these switches and routers, for example, cannot operate without air conditioning. And they have to operate within a certain temperature limit. So I think you've seen this, for example, in some of the roads where we have an electricity pole in the middle of the road, tarmac road. Reason being, the project engineers tried to contact, for example, Kenya Power, so that they can come and move their pole, but they were taking forever. So those are some of the challenges that you encounter in terms of coordination. You have other parties that are not cooperating. The other problem that can affect our project are things like finance. I think most of you guys have seen how this year has been because of the pandemic. So the customer might have planned well for this particular project, and they had hoped that they are still going to be in business. But because of the pandemic, business has gone down, their finances have gone down. So what happens? Other than this, some of the other financial factors that you need to take care of include things like the exchange rate. things like inflation, currency inflation, national interest rates. So some of those things can actually affect your project. So really, those are the exterior risks that we must try and understand and know how we can minimize their occurrence or actually minimize their impact in case one of them occurs. Now, there's something I had read and I was actually to search about it, but I forgot. As the engineering project, some of these things can actually be captured in your project contract in what we call a force majeure clauses. Sorry, I think I left an E here. So I don't know if Alan is here or Gadudi. You guys are in the industry and most likely you're aware about this clause. Can someone tell us, or anyone else who's aware about the force majeure clause? Can someone tell us something about this? Anyone? Okay, so I'm just Googling force majeure. Okay, so in law, it means unforeseeable circumstances that prevent someone from fulfilling a contract. So that is what we call, let's say the pronunciation. Force majeure. Majeure. Hey.
Force majeure. Force majeure. Force majeure.
Force majeure. Unforeseeable circumstances that prevent someone from fulfilling a contract. So please, 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 always make sure that some of these risks are actually captured under your project contract under a force majeure clause. Okay, so let's move on and look now at the projects. We now want to look at the project objectives. Now, project objectives are important and they can be divided into business objectives and technical objectives. So business objective is the final objectives and meaning of a network project. So what is the final meaning? So for example, it can be adding profits, cutting costs, improving production efficiency, etc., etc. Then technical objectives. These facilitate the realization of business objectives and guides the implementation of the project. So what they really want to achieve. So some of the objectives are to improve the production efficiency, support service expansion. You want to open another campus or other labs within the university. You also want to optimize and update your technology. So these, among others, are some of the project objectives for a business. Project budgets, normally this refers to the cost of implementing a project. It might include the financial, labor, and material cost. Financial, labor, and material costs. Now, the business objectives that we've just looked at must involve what we call the return on investment. ROI, return on investment. So from this investment that we are making, we should be able to get the same value from that particular project and more. Now, in coming up with a project budget, there are two ways. There are two ways that we can do it. We can either use what we call the top-down approach or the bottom-up method. Now, top-down is when the project costs are estimated according to a previous project that has been done either by the engineering team or by the customer team. So here we depend on historical data on top-down. So we did a similar project in University A. They have the same number of students, same number of staff, or approximately the same. It costs us 20 million. So we project that here, it's also going to cost us 20 million plus or minus 15%. So that's the top down. The bottom up approach is when you divide a project into subparts, and now you come up with the fees for each part. Then you add them together. So here the total budget consists of fees of each part of a project. So that is what we call the bottom-up approach when it comes to creating budgets. Okay. So the composition of the cost is normally referred to as the TCO. The composition of the total cost is what we call the TCO, or the total cost of ownership. In a network project, these might involve the investment, the construction investment cost, the operation and maintenance cost, and the optimization and reconstruction cost. Now, the construction cost is one of investment. For example, the money that you're using to buy a router, to buy a switch, to buy cables, to buy air conditioning systems, and any other matching system that is needed. So it is closely related to the project objectives. So it includes device costs, matching facility costs, and the engineering costs in terms of the what you're paying the organization that is implementing that project. Operation and maintenance. So your network will constantly require operation and maintenance. Some of the costs involved here, for example, are the energy bills, electricity bills, consumption, line maintenance, repairing, personnel costs. You most likely will have someone monitoring and managing the network. Consumption might be the bandwidth, for example. So you're paying your ISP for that particular. So those are some of the examples of operation and maintenance cost. And regularly, when you want to expand your service or improve your speeds or extend your network so that it can support more students, for example, then you need to do optimization and reconstruction. Normally, this is actually part of another project. And that's why in the beginning, it is difficult to calculate this particular cost. Okay. Now, we've seen that, for example, in finding the total cost of ownership, we need to find the construction cost. To do that, we need to obtain original quotations. For example, when we want to purchase the devices like the switches and routers, you need to find the quotation. For example, for Huawei equipment, you can be able to get quotations from what we call channel service providers or authorized service providers. So you can be able to get them from channel service providers or authorized service providers. There's actually a link which I think is shared in a later document, which can actually also show you some of these service providers. The other thing you need to be aware of is the line construction. So line construction is the fee that you need in order to do cabling within the local area network. Then if you're leasing lines in order to connect to your ISP, you also need to include that fee. So for example, for leasing, you need to obtain the quotation from the carrier. So again, you guys, do you know some of the carriers? Some of the carriers in Kenya? Anyone can give us an example of people who lease lines? I'm sure you know them. Anyone? Does Jamii Telecom deal with leasing lines? They lay down fiber cables that can be leased.
Yes. They do.
Which other one other than Jamii Telecom? Okay, so you can also research about some of the common carriers in Kenya. Now, the other quotations you might need are quotations for the racks, the uninterruptible power supply, air conditioning system, electricity, and so on and so forth. So for these ones, again, you need to contact the salesman for the corresponding vendors. So that's how you obtain the cost from the quotations. Okay, so again, during planning stage, we need to find the technological roadmap. So let's look at that and what it means. Now, in the technological roadmap, we need to do a technological requirement analysis. Now, in doing the technological requirement analysis, the most fundamental technological objective that we are supposed to consider is the network function. So this network function serves as the basis. It serves as the basis for the other technological requirements. So after understanding the network functions, we can now be able to specify what we want in terms of performance, in terms of availability, extensibility, and feasibility. Now, performance may include many aspects, but one of the main aspects of performance is throughput. When you talk of throughput, we mean, for example, bandwidth and how fast packets are processed. So normally performance really depend or is affected by things like the bandwidth of the line, the bandwidth of the interfaces of your device, also the processing power, and the switching capacity of the devices that you're using. So in order to determine performance, you must consider some of those things. So network performance also includes parameters such as latency, which are delays, and also packet loss rate. So you must try as much as possible to minimize latency and packet loss ratio within your network. Availability is the ratio the ratio of uptime to downtime. So it actually indicates how tolerant your network is to network faults. Now, most of the time, we want to ensure that faults do not affect the operation of our network and interrupt services. So one of the components that is closely related to availability is what we call recoverability. So how fast can your network recover from failure? So most of the time, to ensure availability, of course, we implement redundancy. In order to improve availability, because we've said it's also closely related to recoverability, we also need to ensure that we follow all the procedures that are needed so that we can be able to quickly troubleshoot our network in case we have problems, and we can be able to bring it back as soon as possible. The other important aspect of technological requirement analysis is extensibility. Extensibility is sometimes also referred to as scalability. So can your network grow in order to meet service expansion? So for example, I said that in 2010, MMU had about 2,000 students. In 2020, we are talking of 7,000 students. So can that network be able to grow in order to meet the growing number of students? So that is what we call extensibility. And we're going to look at some of these things in more detail. Then the other technological requirement that we need to consider is feasibility. Feasibility. So what this means is that the technological requirement should actually be available at that particular time. So you cannot have technological requirements that are beyond what the current technology can support. So it means it's not possible, it's not feasible. So we must never specify unrealistic requirements. So in terms of speeds, in terms of bandwidth, so for example, maybe right now we have interfaces that can support up to 40 gigs. So you cannot specify 50 gigs, for example. Just as an example, I'm not saying we don't have 50 gig. So that is what we establish when we are looking at feasibility. So we have to use realistic technological requirements. Now, the other aspect is on service traffic characteristic analysis. Normally here, we aim to understand the service traffic that needs to be transmitted in our network. Some of the aspects that we look at is the traffic characteristics. For example, the traffic path, the traffic type, and the load estimation. So the path really, we've done things like quality of service in the previous modules and how to control traffic paths. Traffic type, we know we have, for example, voice, video, and data. Some of them are real time, some of them are non-real time. So you need to understand them. And the load estimation of each of the traffic type. What amount of bandwidth is it going to consume? The other thing we need to understand about this is behavior characteristics. For example, the number of users in our institution, the service model, and also the time model. So when you talk of time model, we are talking of peak times and non-peak times. When do most people access the network? Also, service model is what services are the most common. So that is behavior characteristics. And after understanding the type of traffics that we're going to have and their behavior, then we can come up with a quality of service requirement. So on the service level, we are talking of which service, which traffic or service type are highly prioritized. So for example, voice, real-time voice data. And then we need to come up with QoS indicators and QoS model so that now we can be able to configure, this. So these will ensure that the bandwidth is actually used optimally. We avoid latency and jitter for real-time traffic. So that's why we need to do service traffic characteristic analysis. Now, when implementing a network project, we must understand whether the network is dedicated or built on a public network platform. So dedicated or built over the public network. Normally, the local area network, like the network at MMU, is a dedicated network. When we talk of a dedicated network, we mean it is owned by us and we have total control and ownership of the network infrastructure. So that is what we call a dedicated network. When you talk of public network, we normally refer to the wide area network. And normally, MMU will lease part of the devices on the public network or construct what we call a VPN technology, VPN, a virtual private network, over the public network. For example, when we want to connect to our ISP, or we want to connect to a different campus. Just a moment. So that is the difference between a dedicated and a public network. Now, generally, the advantage of a dedicated network, for example, it's very secure, while for this one, it is low cost because we are sharing. So, for example, when we are using leased lines. On the other hand, here we have dedicated devices, they are ours. The lines within our campus, they are ours, and we manage it autonomously without interference from anyone else. So that's the difference between a dedicated network and a public network. Okay. Now, we have two things that we need to understand here. Generally, current networks are based on either a modular or hierarchical design. Actually, not or, and both of them. We have the modular design and hierarchical design. The modular design is used to specify the modules that are required in a network architecture. These modules, for example, can be the LAN modules, the WAN module, the data center module, the wireless access module. So you see, we're looking at the wireless network as a module. We are looking at the local area wired network as a module. We are looking at the interconnection to the ISP and other campuses as a module. So that is what we're calling modules. Now, when it comes to hierarchy or hierarchical design, we are specifying layers that are used in the network architecture. So we are going to see two major layers that are used, or hierarchical designs that are used. Traditionally, we use the 3-layer network structure. And we're also going to look at the flattened two-layer network structure in a short while. So I hope you get a clear difference between what a network module is and what a network hierarchical design is. Okay, so let's look at a project case in order to end this first part. So can someone read for us this particular scenario? And it's important that we understand it because we're going to be building on this scenario as we go forward. So a volunteer to read for us this scenario.
Okay, I'll read.
Okay, please go ahead. Thank you.
Once a time, the department manager of a network integration company assigns a network project to Mr. Wang and Mr. Song. Mr. Wang takes the role of an engineer and Mr. Song assumes the responsibility of a sales manager. Question 1, what can Mr. Wang do in the next phase? Question 2, what should Mr. Wang prepare for the project?
So any suggestions? So who's the techie here, by the way? Mr. Wang or Mr. Song?
Mr. Wang.
Okay, then Mr. Song is the
Sales manager.
Sales manager. So do you remember that that organizational structure that we looked at? So here, Mr. Wang, because he's the techie here, number one, he needs to work with the sales manager in order to track and survey the project. Now, while Mr. Song is the one that is going to conduct the survey, Mr. Wang is actually the one that is going to come up with the questions and understand and actually guide Mr. Song in understanding how to frame the questions and how to ask them so that they can be able to get the customer requirement. So that is actually what Mr. Wang needs to do in the next phase, really to do the surveys in order to get information from the customer. Then what should Mr. Wang prepare for the project? So as the techie here, what does he need to do? What do we do at the end of the project planning? Okay, so really, Mr. Wang should then prepare the questions that are needed for the survey. Then Mr. Song will conduct the surveys, and eventually, after getting clear project requirements and all that is expected of the project, they also need to do a final report for this particular project. So that is really the very first stage of implementing a network engineering project, which is what we call the network planning stage. Now, Mr. Wang, scenario 2, Mr. Wang goes with the sales manager to the customer for project survey. So what questions should Mr. Wang prepare? And who should be talked to in order to find the answers? So when we go to the customer, who should we talk to in order to find the answers of our questions? Remember the questions here, we need to understand the project objectives, the scope, the organizational structure, any matching systems that are needed. So who are some of the people that you think we should talk to when we go to the customer end?
I'd say the people live in that within that particular area.
Really, just talk of talk in regards to the organizational structure that we looked at. So should we talk to the project manager? Should we talk to the project contact person? Should we talk to both of them? Who should we talk to? Here, who should we talk to? Project manager, project director, or project contact person, or all of them at different times? So the initial stage, of course, we might need to talk to all of them. Maybe we can start from the project manager in order to understand the higher level information about the project. For example, the budgets, their technological inclination and such things. Then we talk to the project director about, again, their technological inclination and how they want us to carry the project. And also the contact person, just to get information about the issues they have realized, for example, with their current network, if they have any, and any other information that might be important. Now, the next question here is on some questions may not have definite answers. So how should they handle it? For questions that do not have direct answers. This might be because, for example, the person you're asking, they're not familiar with the technical issues that you're asking them about. It might be the project manager, but they're not familiar. So what happens? How should you handle that situation? Now, in such cases, you need to cooperate with the customer in order to find a solution. How do you do that? You, as the engineering party, should give a detailed explanation. Then you present alternatives to that particular technological requirement that you're suggesting. Then you guide the customer to make a choice. So it is your responsibility to guide the customer to make a choice when you're asking about things that they are not familiar with. Okay, so that is the end of this chapter, ladies and gentlemen. Can one of you take up question number 1 and another volunteer to take up the next one? Anyone? Which of the following issues are going to be resolved during the network planning? Do we determine the technical solution during planning? Yes or no?
No, I think no.
Exactly, no. Otherwise, we are supposed to know about the background of the project and also determine the project requirements. Which of the following issues needs its scope defined within a project? The scope. Do we need to find the functional border, the engineering border, and the coverage?
Yes.
Yes, we need to find out about all this. Okay. Thank you so much.